So our next guest calls himself a designer in the Bitcoin space. I call him a badass creator and artist. And just as Julian was talking about, really seeking out beautiful artwork. You know, some of us are visual learners, some of us are audio learners, some of us are kinetic learners. And so it's important that we share the message of Bitcoin and the hope that Bitcoin brings through many different mediums. And so we're going to be treated with the anatomy of Bitcoin that has been created by Pedro, and he is going to help us hopefully visualize the most beautiful network that's ever been created, other than human life. Let's go, Pedro.
Hi. Thank you, Valerie. Hi. I'm here to talk about what I think Bitcoin looks like. I think we all know that Bitcoin can mean different things for different people and look different ways to different people. A lot of people see memes, a lot of people see logos, a lot of people see personalities. But I was trying to find a way to visualize it in a more anatomic way and break down all the elements and bring them into the 3D space. So kind of do away with all the metaphoric illustrations that we tend to see in the mainstream media, the too complex technical explanations and the too reductive diagrammatic, to really go into the spatial understanding of Bitcoin. I've been working on a lot of different Bitcoin projects, UI, design, some development, trying to develop games and trying to elevate the basic building blocks of Bitcoin, like the source code, into something that people can use and explore, not just through other people's content, but by themselves. And after doing all these pictures, why not also try to do a motion picture? So the idea is to build an open source film that people can watch with their families, and it's something that can circulate the world, but will explain Bitcoin in a very direct and very precise manner. Here's a test of when we started working on this. We see the different layers of the network. We have the nodes all connected to their peers. We can zoom into the node, see what's happening inside the node, the different components that enable the node to process the information that comes from the network, like the validation, the mempool, the connection with other nodes. We can look inside and see how the messages are transported from node to node and then ultimately added to the blockchain that enables us to have the ledger of all the transactions. And the idea is to set it to some beautiful soundtrack that other Bitcoiners are already working on, that we can really entertain but also surprise and delight the viewer of any walks of life. It can be old people, young people. Hopefully this film can touch everybody equally. So here we go to the chip of the chain, and we see what's inside the block, and we see all the transactions, the Merkle root. So this is 2020, a very fast test. We're trying to create images that can represent Bitcoin, but in a very precise way. And how do we do that? We go through the whole protocol and we try to break it down into different chunks and explore one at a time. And we can let that be the driver of the film's narrative. And obviously each component has other components that we need to explore. Ultimately, it would be ideally a 2-hour film, but this can be released in a series of films, or it can be released as a longer or shorter film. And tying it back to Julian's talk, who will pay for that? Right now, the model is everything is funded by you, the Bitcoiners. We have a lot of organic donations that came through our website. We also use Geyser. People have donated 21 sats to millions of sats. We also have contributions from other Bitcoiners and other non-Bitcoiners that contribute to code that's essential to build the movie. And then we have collaborations with other Bitcoiners that are more interested in the editing and the the music composition that just take whatever this project creates, and they're free to engage with the images however they want. It's all under MIT license. And obviously, counting on the support of the other initiatives that happen in Bitcoin. Also, like to thank the support of Bitcoin Magazine that's been very helpful in broadcasting and distributing whatever's already done from the film. We would like to credit as a different producer, as a simple producer for a film. And we're especially thankful to Bitcoin Magazine because we've also been able to inject elements of the film in a lot of the conferences that they've been throwing. So, is it reproducible? The idea is to take data from Bitcoin and put it into 3 dimensions. We connect to our node, we parse the information from the blockchain, we then put it in the Blender software, which is a 3D open source software that runs Python scripts, and then with the data that we collect from the chain, we can then build geometry. So in this case, you're seeing how the blocks are distributed in the beginning of the chain, and the separation between each block is based on the time it took for them to be found by the miners. And this causes an interesting problem because we're trying to represent time, but we're not so interested in the human time, but more in the Bitcoin time. So we have 10 minutes, we have 2 weeks for the 2016 blocks for the difficulty adjustment. We create a spiral, then we stack that spiral into a helix, and that's how we represent Bitcoin, or the blockchain at least. Here we see the Genesis block with the 9 days of no mining that happened between the Genesis block and the other blocks that you see in the bottom. Here we see a more recent moment in the blockchain where you have blocks that exceed the 1 megabyte limit, which is this gray cube, and those are most likely SegWit blocks. And we can see that if we take one of these helix, we can see a very standard distribution of the blocks because obviously it averages on 10 minutes, but there's no block that actually is being mined in precise 10 minutes. And we can take all the other difficulty adjustments throughout the history of Bitcoin, and we can see that in the beginning the blocks were empty, so we see it more dim, very unstable moments in the mining, because sometimes you see moments where there's no blocks, probably computers left the network, and sometimes you see high concentration of blocks, that's probably better hardware or more computers joining the network. This is a close-up of those spirals, just to see how the blocks are distributed and the distanced from each other, but also how they're packed with data as we move closer to our present time. This is an animation of all the stack. You see in the beginning, big fluctuation, but these disks are trying to aim at that moment, at that 2-week target. And we can see them getting fuller and fuller as time goes by. And this is the chain tip at the time this was made, which was 2022. For those following the more recent events on the chain, this is when ordinals started. We see the dimension of the blocks increasing dramatically. We can also map the mempool by taking data or just visually matching it to the charts that already exist from other projects. And we place the mempool by the tip of the chain because those are the transactions that are most likely to be added to the tip of the chain. And this, I hope, will help people understand that there's moments where it's very hard to get into the chain with your transaction, but there's moments where the mempool is empty and it's very cheap to be added to a block. We can also look at the UTXOs, and along with the mempool, which is one of the most volatile elements of Bitcoin because it's always changing. People add transactions and replace transactions, but also the UTXO set updates with every single block that's added because transactions are always consuming outputs from the past. So if we have imagine a set being the smallest unit in Bitcoin, all the way to 100 million sets. We get a rough representation of Bitcoin. Here we have 50 Bitcoin, the original block reward. This is what it looks with this model inside a Bitcoin. It's just an explosion of particles, of sats. But then we can map those into a block. So every single block has a set amount of Bitcoin that can be spent in the Coinbase, but also people have moved Bitcoin to transactions that are sitting in those blocks and spent. And we can, for each block, create a sphere that represents the amount of Bitcoin that exists there. And once we input real data, we see the confusion that exists on chain. So here's another test. We have the layer of blocks that never changes. Once it's set, it's set. But then there's a layer of UTXOs associated with each block that will always be changing. And you can see that there's blocks that have no Bitcoin and blocks that have a lot of Bitcoin. We can also look at the data in a more raw way. Here we have the binary version of the data, the hex version of the data, a tagged version that calls out all the important script opcodes of Bitcoin and tags them. And then we have a more parsed out version of the blockchain that just actually calls out everything that's in the data. We can also look at the data that sits on everybody's blocks and have a hex dump of the first block dat file, where basically your node stores all the data. And that line up top, that represents roughly the size of the Genesis block. So it's one line of roughly, I think, 200 kilobytes. No, byte. And here we see around 1,000 blocks. This disturbance that you see here, this is actually when on block 170, when Halfini got the first block, the first transaction. So there's a block there that's special. It's a block that has one extra transaction than all the preceding ones, and that's why it creates this break in the pattern. More recent blocks with the same view, we can look at how miners like to organize their transactions in their blocks their own way. Here is like a slice of a more recent DAT file. Here we see maybe 5 blocks, and you see the different patterns that the way miners organize their transactions create. Another visualization where it's a little bit more broken down. The bit by bit visualization of a private key. These are 256 bits. This is an actual private key. So you can visualize what a private key looks like in three-dimensional space, not just with words, but with bits. And obviously, these are also all laid out with code. So we input a binary, and then geometry comes out. Would also, hopefully, this is the goal for me, but hopefully for other people too, will create a sensibility towards how much space data occupies and how much effort there is to validate and parse that data. And here's a more recent animation of the Genesis block. We go bit by bit. First we have 8 bits, zeros and mostly zeros and a 1. So that 1 is signaling the version of the block. And afterwards comes the previous block hash, which in this case is a set of zeros because Genesis block doesn't have a preceding block. So we build up all the zeros, and then at the distance we can start seeing any moment now. We see the rest of the element of the block header, which includes the Merkle root hash, the nonce that was used to mine that block, and the number of transactions existing in this block. which in this case is just the one Coinbase transaction. So we break a line and we keep building. Now we're building the Coinbase transaction for the first block, which also consumes an empty output that doesn't exist. And then we go on to signal that we're going to sign the transaction. And it's obviously in the signature of the Coinbase that Satoshi embedded the message that we all know. We're also, at the same time that we're building with just the bits, we're also putting the layer of the hex and the ASCII in Latin 1. So we have the three different ways of visualizing the data. So from here you get an idea of what can be accomplished. We can talk about sizes of blocks, how many transactions fit in a block, how the transactions connect to each other, what is the history of each transaction, to also create some awareness of that you need to be aware of where your UTXOs come from, so you're not to dox yourself or hurt yourself. We can also look at the amount of Satoshis being moved in each transaction. We can also talk about the cryptography behind that Bitcoin uses. In this case, we're mapping the elliptic curve that Bitcoin uses under real numbers next to all the adjacent curves. And then we can also plot it in three-dimensional space because it uses module arithmetic. So once you, instead of going to infinite, it actually rotates on both axes. So the space, the mathematical space that we're dealing with is actually this torus-like figure. And then that line goes pretty much all the way, and points in that line, just the prime points, is where your Bitcoin is hidden. The secret is somewhere in that line, your secret. We can also look at the network. We can map the network by asking our node how many nodes it sees. We can also go to other services like BitNodes. They have been collecting more reliable data on visible nodes in the network, and they also, we can also derive their location in the world by their IP address. Obviously, not all of them have IP addresses because we're also dealing with the Tor network. So here we see a visualization of the Bitcoin network, maybe 10,000 blocks ago, that are the blocks that are more distant from the geography and the confines of the physical space are the Tor nodes that are untraceable, at least to a certain extent, and then the ones that are close to the geography are the nodes that we know where they are. And what is a node? We represent a node as a sphere that has connections. Information moves through those connections. Once it hits the node, the data explodes. It gets processed by the node as if it was inputs in a factory. They need to be processed before they add it to the chain. So here's a node handshake. It sends a message out, it gets a message in, and then it starts exchanging information with the other nodes. We can also look at Lightning. So in this case, this is a rough representation of a Lightning node that has transactions that open the channels connected to the chain. And imagine that we have a payment coming through our node, and it immediately rebalances the channels according to the amount of sats that move through the node. We also look at the code, the multiple versions of the code. right now more interested just in the alpha version of January 3rd. We can also look very extensively at whoever got any merge, any code merged on the main repository of Bitcoin Core. And I think something that's really interesting is to demystify the complexity of the code and actually explore and explain code line by line, because even though it's C++, the functions, the classes, there's a lot of English language here that can be understood by most people. We can also look at miner. The idea of a miner is that it has an array of chips that produce hashes, and until it finds a valid hash, those hashes are wasted and kind of flow into the air. And this would be kind of a mapping of the mining pools on top of the network. And I have a lot more to explain, but unfortunately I'm running out of time, so I'm gonna skip towards the end and invite you to collaborate in any way you want by either donating your time, your money, helping produce, write, edit, code, distribute, or anything else that needs to be done to bring a film to the masses, if the masses are interested. It's an open source for and by Bitcoiners, hopefully. So thank you very much.